In this video, we are going to learn about square root graphs, including their domain and range. The graph of f of x equals the square root of x will be the parent graph of the square root graphs. Let's complete a table and then make a graph. Now, when working with the real numbers, we cannot take the square root of negative numbers. So the square root of -4, since we're only working with real numbers, that doesn't apply. Same thing with the square root of -1. The square root of 0, well, that equals 0. The square root of 1 equals 1. And notice I skipped to 4 because that's the next perfect square root. Square root of 4 is 2, and the square root of 9 is 3. All right, so now we have these points. And we'll go ahead and graph those. There's our graph of y equals the square root of x. Notice it has an endpoint and then continues forever in the other direction. Also notice the steps that we take to get these 3 basic points here, or 4 basic points. We have our endpoint. And then since the square root of 1 is 1, we went over 1 and up 1. And from the endpoint, to get the next point, we went over 4 up 2, because the square root of 4 is 2. And then we ended up with 9, 3, because the square root of 9 is 3. We'll be seeing these same steps again with other equations. Let's take a moment to investigate what happens to the parent graph when we add or subtract a constant after the square root sign. So here we have the parent graph. And here we have the graph of y equals the square root of x plus 3. And here we have the graph of y equals the square root of x minus 3. And we notice that adding or subtracting a constant after the square root, it just shifts the parent graph up or down. In fact, adding a constant outside moves the graph up, and subtracting a constant outside moves the graph down. Right, so adding and subtracting a constant after the square root works just like our common sense would hope it works. Now let's investigate what happens when we add or subtract a constant inside the square root sign. So first I'll graph the parent function. Next I'll graph y equals the square root of x minus 2 inside the square root sign. And finally I'll graph y equals the square root of x plus 2 inside the square root sign. Okay, and we notice that adding a constant, that was this graph, that moves the graph left. So it's a little bit opposite of what our common sense would hope it would be. And subtracting a constant, that was this one, that moved the graph to the right. Now you can always go to desmos.com and use their graphing calculator to look at more examples like these. All right, so to summarize, so inside the square root sign, when it's positive, that moves the graph left. When it's negative, that moves the graph right. The constant afterwards, when that's positive, it moves the graph up. And when that constant after the square root sign is negative, it moves the graph down. Now HK, that tells us our endpoint. Now notice the way this kind of recipe is written here is I already have the subtraction sign there. So that's taken into account the fact that it's backwards. So our endpoint will be HK. Okay, so let's graph f of x equals the square root of x minus 4. So we're going to move the parent function down 4 units. Well, normally the endpoint is at 0, 0, so we're going to move the endpoint down 4. And then from there, we can just kind of mimic the parent graph. The square root of 1 is 1, so when we move over 1, we move up 1. The next perfect square root is 4. So the square root of 4 is 2. So when we move over 4, we go up 2. And when we go over 9, we go up 3. So notice we do not have a straight line here. It is definitely a curve. And there's our graph of y equals the square root of x minus 4. Now let's graph g of x equals the square root of x plus 5 inside the square root sign. So that's going to move it left 5. Normally the endpoint is at 0, 0. So we'll go left 5 units to put our endpoint. And the square root goes over 1, up 1. And from the endpoint, we move over 4, up 2 for that next move. And also over 9, up 3, since the square root of 9 is 3. And there's our graph of y equals the square root of x plus 5 inside the square root sign. Square root graphs offer a great opportunity to practice domain and range. Now in a graph, the domain represents all the x values that the graph covers from left to right. In a graph, the range represents all the y values that the graph covers from bottom to top. Now these aren't square root graphs, but let's practice with our domain and range. So here we're looking for this line, what x values it uses. So the x values that this line uses is from -7 to +6, not including those endpoints, because notice those have open points. So x is in between -7 and +6. Notice I did not use equal bars underneath by inequalities, because those endpoints are not included. The y values this graph uses also happen to go from -7 to +6. So here I'm looking at the y values. Now in this graph, the domain will be the x values. Now here the endpoints are part of the domain and range because they are closed points. So once again, the domain is from -7 to +6 because I'm looking at the x values that this graph uses. So x is in between -7 and +6, including -7 and +6, so I put the equal bars. And the range only goes from 0 to 5. Those are the y values that this graph uses. So we have y is in between 0 and 5, or 0 is less than or equal to y, which is less than or equal to 5. Let's try a couple more. Now here, we can use any x values out to -infinity and +infinity, because those arrows say it keep going. So we could say all real numbers, or we could say x is in between -infinity and +infinity. And the range, well, this line only uses one y value, and that's the y value of 2. So we just say y equals 2. Now for the domain here, we're thinking about what x values this graph uses. Well, to the left, it'll go all the way to -infinity, but to the right, it doesn't go past 3. So we can say x is in between -infinity and +3. And I put a little equal bar there because it does include 3. And then the range, this will keep going down to -infinity, and this will keep going up to +infinity. So y is in between -infinity and +infinity. So let's go ahead and graph this equation and then figure out the domain and range. So once again, we have a square root graph. and it's going to move the endpoint compared to the parent graph left 5 and up 1. So normally the endpoint is at 0, 0. On this one, we're going to move it left 5 and up 1. So here's our endpoint. And then from that endpoint, we're going to go over 1 up 1, since the square root of 1 is 1, and over 4 up 2, since the square root of 4 equals 2. Let's get one more point on there. And we move over 9 up 3, since the square root of 9 equals 3. And those moves are from the endpoint. So from this endpoint, I went over 9 and up 3. So for the domain, the x values this graph uses are all the x's greater than or equal to negative 5. So we just say x is greater than or equal to negative 5. And the range are all the y values this graph uses. And this graph will go up all the way to positive infinity. So it's all the y values greater than or equal to 1. So we say y is greater than or equal to 1. So for this square root graph, compared to the parent graph, we're going to move that endpoint to the right 2 and down 5. Normally the endpoint is at 0, 0. So I'm going to move that endpoint to the right 2 and down 5. So here's where my square root graph will start. And from there, I'll do my normal parent graph moves. The square root of 1 is 1, so we go over 1, up 1. The square root of 4 is 2, so I'm going to go over 4, up 2. And that's about all the room I have. All right, this graph will use x values greater than or equal to 2. So we can just say x is greater than or equal to 2. So those are the x values this graph uses. And the range, well, the y values this graph uses. This graph actually will go all the way up to positive infinity. So this graph uses all the y's greater than or equal to negative 5. Okay, I hope these examples about square root graphs and domain and range have been helpful. This is Mr. Ela signing off.